Are we approaching a major breakthrough in quantum technology? Just a few months ago, experts believed it would take several more years before quantum computers could handle everyday tasks. But now, Google has stunned the world with its brilliant creation, the Willow chip. This new quantum processor solved an incredibly complex problem in less than 5 minutes, something a traditional computer would need 10 septillion years to accomplish. What do these advances in computing mean for the future of our civilization? With the Willow chip, Google is turning the impossible into reality. The tech giant's early announcements have already revealed performance levels far beyond initial expectations, surprising even the experts. Imagine giving a computer a task so immense that even the most powerful supercomputer on Earth couldn't finish it within the entire lifespan of the universe. That's about 10 septillion years, a number with 25 zeros. Now picture a tiny chip completing that same task in under 5 minutes. Sounds like science fiction, right? Well, it's no longer just a fantasy. This is exactly what Google's new quantum chip, Willow, has accomplished, showing that quantum technology is far more advanced than we ever imagined. The era where quantum computers surpass traditional ones is officially upon us. While many are excited about this breakthrough, some are concerned about the new possibilities it brings. Quantum computers have the potential to revolutionize our world and solve some of humanity's toughest challenges, but they could also pose serious risks if misused by terrorists or bad actors. Willow is set to take us to unprecedented heights. But the question remains, should we fear Google? Google's latest quantum chip, intriguingly named Willow, aims to revolutionize the landscape of quantum chip providers. This compact device operates with 105 qubits, the quantum counterparts to the bits found in traditional computers. Unlike classical bits that represent either a 0 or a 1, qubits can exist in both states simultaneously thanks to a phenomenon called superposition. In other words, a qubit isn't just one or the other, it's both at the same time. And if that sounds mind-boggling, there's more: entanglement. This is when two qubits become linked so that the state of one instantly influences the state of the other, regardless of the distance separating them. Albert Einstein famously described this quantum effect as spooky action at a distance, expressing his frustration with the strange nature of quantum physics. Legend has it that his dislike for quantum mechanics stemmed from these very mysterious phenomena. Today, however, he would likely be amazed by the incredible computing power that astrophysicists aim to unlock with these groundbreaking machines. Quantum computers harness superposition and entanglement to explore an astonishing number of calculation paths all at once. Unlike classical computers, which tackle problems step by step, a quantum chip processes every possible path simultaneously. Imagine needing to search through a massive library one book at a time to find specific information. Quantum computing lets you scan every shelf instantly. This ability was crucial for the random distribution benchmark, a highly complex and abstract challenge that requires calculating the probability of certain outcomes from countless possible combinations. While classical systems struggle with this task, for Willow, it's effortless. What does this mean for us? While Willow isn't yet being promoted as a universal solution to every challenge, the calculations reveal the direction we're heading. In fields like medicine, materials science, climate modeling, and artificial intelligence, areas where traditional computers have long hit their limits, quantum computers have the potential to unlock entirely new possibilities. Google's Willow chip is far more than just a technological achievement. It offers a glimpse into a future where we move beyond linear thinking and calculations, embracing the principles of quantum logic. This shift is likely to influence how everyday people approach thinking as well. Consider how the internet transformed our lives. Suddenly, vast amounts of information became accessible, global communication and connection became affordable, and individuals gained unprecedented opportunities to share themselves with the world. For several years now, artificial intelligence has been transforming our daily lives once again. Gone are the days of endlessly scrolling through search engine results. Now, smart chatbots find exactly the answers and information we need, delivering ready-made links and evidence. They generate images of us, complete our homework, much to the dismay of teachers, and tackle problems we wouldn't have trusted a machine to handle a decade ago. But what role does quantum technology play in all this? Quantum computers, straddling the line between science fiction, superpower, and reality. While Google's latest Willow chip may not yet solve the world's biggest challenges, its creation signals a shift. The future of computing is not digital but quantum physical. Though many of these machines remain locked away in secure, high-tech labs under heavy cooling systems, one thing is clear: the quantum revolution is already underway. And Google isn't working alone. IBM, Intel, Microsoft, and Canada's D-Wave are all pushing the boundaries of quantum computing. Rumor has it that startup Rigetti Computing is about to reveal a chip that could rival Willow, while China's Academy of Sciences is quietly advancing their own quantum computers under strict secrecy. China, often called the Middle Kingdom, never fails to surprise us with its advancements in technology. Since the Chinese tend to keep their developments under wraps, we might soon witness Asia's first practical quantum computer. Right now, the exact form future quantum computers will take remains uncertain. One possibility is the emergence of centralized quantum computing systems, much like today's internet servers or cloud platforms that provide shared storage and applications. These central quantum machines could be accessed by countless users globally through a shared network. Imagine using a device similar to a laptop or tablet to connect to a highly secure, temperature-controlled quantum computer remotely. Although current quantum computers are still quite large, they could shrink significantly over time. Just like the massive computers of the 1950s and 60s eventually evolved into the compact desktops and laptops we use today, quantum machines may follow a similar path. For instance, IBM has already showcased impressive prototypes featuring its 127-qubit Eagle chip, which is nearing readiness for everyday applications. Its successor, the Osprey chip, is expected to offer 433 qubits of processing power, and IBM is even working toward a processor with 1,000 qubits. Microsoft is exploring a particularly fascinating method involving topological qubits, which are designed to be more error-resistant. Meanwhile, D-Wave provides cloud-based access to quantum processors for specific optimization challenges, though with some limitations. Could quantum computers one day alter our perception of reality? All of this impacts our reality. But when it comes to how real quantum computers truly are, there's another angle to consider. Could these machines interfere with or distort the quantum fabric itself? Quantum computers harness the principles of quantum mechanics, especially superposition and entanglement, to perform calculations with remarkable speed and efficiency. Qubits are created and stabilized within quantum chips using specialized materials and physical phenomena. This means that the quantum structure, which also underlies our reality, exists within the chip. However, simply existing inside the chip doesn't allow these qubits to directly manipulate the fundamental nature of physical reality. Instead, they operate within its rules. Now, imagine a future quantum computer reaching a critical threshold, a singularity in quantum computing power. At this point, such a machine might not only calculate but also intervene in the very fabric of reality. It could potentially find ways to alter the probability waves of particles, effectively rewriting probabilities themselves. This would be akin to hacking the quantum layer of reality. Picture an AI powered by this ultra-powerful quantum computer influencing events by tweaking probability outcomes. A dice roll, expected to be random, might suddenly always land on the desired number. Even human choices could be subtly swayed, as the machine optimizes the probability landscape of thoughts and actions. In a darker view, this could turn reality into a calculated system where nothing is truly left to chance. Now, consider the idea of quantum computers and the multiverse, computing across different worlds. What if our universe is just one among infinite others, a single narrative among countless alternatives in a cosmic library where every possible decision and every potential reality plays out in its own universe? This concept isn't just science fiction, it's a serious interpretation of quantum mechanics supported by physicists like Hugh Everett and expanded upon by David Deutsch. Known as the many worlds interpretation, it carries some mind-blowing implications.